Hi everyone. Today we are going to discuss the one of the basic neural network that is called as McCulloch-Pitts neural network. The author McCulloch and Pitts, okay, these two authors developed this basic neural network. That is, it is called as McCulloch-Pitts neuron model. Okay, see, this is the very basic neural network. That is, this neural network was developed in the year 1943. So this is the first artificial neural network model that is applied to the logical function. Okay, so AND gate, OR gate, XOR gate. Okay, so when the output is in 1, when this output is 0, that is we have to find out based on this weight updation. Okay, I have to get this value. Okay, so first of all, this McCulloch and Pitts neuron model is applied to the logical function. So this is the simple structure of the McCulloch-Pitts neuron model. So here x1, x2, x3 up to xn is nothing but the input signal. Okay, so the input signal is given to the output neuron. So through the connection link, so each connection link have its own associated weights, that is represented by W1, W2, W3 up to Wn. Here there are two types of inputs. Okay, so one is called as excitatory inputs, second one is called as inhibitory inputs. Okay, so excitatory input means the weight have positive magnitude. Okay, with same values. Okay, all the weights are in positive magnitude on the same values. That weight will be called as excitatory. Okay, so another one is for inhibitory weights. Okay, so have the weights is having the negative magnitude. Okay, -2, -1, okay, -3, -7. So this is represented by the inhibitory weights. So all the excitatory weights have the same values. Okay, with positive magnitude. Inhibitory weights are the maybe a different values or in same values. Okay, but that values is in negative magnitude. Okay, so there are two inputs is given to the neuron. Okay, so this input of the McCulloch-Pitts neuron model would be either 0 or 1. Okay, it will be produce output means that is for 1. It does not, the neuron output neuron does not fire means the values is 0. The neuron is fire means the values is 1. Okay, so how we have to decide this neuron is fire or does not fire? Okay, so based on the threshold function of an activation function. Okay, the output signal Y out that is for 1 means if the sum of input is greater than or equal to the threshold value, otherwise it's 0. Okay, so this is the diagrammatic representation of the McCulloch-Pitts neuron model. Okay, so for the understanding purpose, okay, so now already I told this McCulloch-Pitts neuron model can be used for the logical operation. Okay, so AND function, OR function, XOR functions, okay, not functions. These functions normally this McCulloch-Pitts neuron model is used. Okay, for the understanding purpose. Okay, for the betterment of the understanding purpose, let me consider for this simple example. Okay, so here we have to consider the John carries an umbrella. If it is sunny or if it is raining. Okay, there are 4 given situations. I need to decide when John will carry the umbrella. Okay, so what are the situation? The first situation, the first scenario, it is not raining nor it is sunny. Okay, it is not raining nor it is sunny. There is no raining, no sunny. Okay, second scenario, it is not raining but it is sunny. Okay, so that is very hot. Okay, and there is no rain. Third scenario, it is raining and it is not sunny. Okay, so rainy is there, there is no sun. Okay, there is for third scenario. Fourth scenario, it is raining as well as it is sunny. Okay, so you will be consider these 4 scenarios. Okay, to analyze the situation using the McCulloch-Pitts neuron model. Okay, it can be considered the input signals as follows. So x1 is nothing but it is raining, x2 is nothing but sunny. Okay, so there are 2 input values, x1, x2. So the value of both scenario can be either 0 or 1. Okay, we can use the value of both weights x1 and x2 as 1 and the threshold function is 1. Okay, so the neural network model, okay, so we have to develop like this. Okay, here weight W1 and W2. The both weights are in positive magnitude and the same values. Okay, this weight is we called as excitatory weights. That is, we are not considering the inhibitory weights. Okay, so what is the truth table based on this scenario? There is no rainy, there is no sunny. So x1 0, x2 0. Okay, the sum is 0, output also 0. Okay, so what we consider here, x1 is rainy, x2 is sunny. Okay, so there is no rainy, no sunny means the output is 0. So on the second scenario, second situation, there is no rainy but it is sunny means, okay, the sum is in 1, the output is in 1. Okay, so the John, it will carry the umbrella. Okay, so there is no rainy, no sunny means no need to carry the umbrella. Okay, in second situation there is no rainy but it is sunny. Okay, so due to the very hot, okay, the John, he is carry the umbrella. Okay, the output is in 1. On third situations, okay, it is rainy, there is no sunny. Okay, so due to the rainfall, the John will carry the umbrella. Okay, the output is in 1. Okay, fourth situation, there is a rainy, it is a rainy, it is a sunny. Okay, both situation has happened. Okay, so automatically the John carry the umbrella. Okay, the output is in 1. So this is the concept of the McCulloch-Pitts neuron model. Okay, so based on this threshold value, okay, here we have to fix that threshold value is 1. Okay, if y and the summation of the neuron, okay, the output neuron, it will collect all the input signals. Okay, and it will be decide when the neuron is fire and does not fire. If when it is fire means the x value is greater than or equal to 1 means the neuron output neuron is fire. Okay, if the summation value is 0, okay, means, okay, when the x is less than 1 means the summation, the output neuron does not fire. Okay, so this is the one basic concept of the McCulloch neuron model. Okay, thank you.